Welcome to the universe of the mind. You'll be amazed at the things that you might find in a galaxy far, far away. The secrets of our world will be exposed today.
Hey everyone, welcome back to the channel. Today, we're diving into one of the biggest mysteries in the entire universe. Look up at the night sky. All those stars, galaxies, and nebulae you see, all the stuff we can detect with our telescopes. That's less than 5% of everything that's out there. So, what's the other 95%? Well, a huge chunk of that, about 27%, is something scientists call dark matter. But what on Earth, or rather, what in the universe is it? Let's travel back to the 1930s. An astronomer named Fritz Zwicky was observing the Coma Cluster, a massive group of galaxies. He noticed something really strange. The galaxies at the edge of the cluster were moving way too fast. Based on the amount of visible matter, all the stars and gas he could see, there shouldn't have been enough gravity to hold the cluster together. These speedy galaxies should have just flown off into deep space. It was like watching a merry-go-round spin so fast that the horses should be flying off, but they're not. Zwicky proposed that there must be some invisible dark matter providing the extra gravitational pull needed to keep everything in check. At the time, his idea was mostly ignored. It was just too wild. But then, fast forward to the 1970s, an astronomer named Vera Rubin was studying individual galaxies, specifically how fast stars orbit the galactic center. You'd expect stars farther out to move slower, right? Just like how Pluto moves much slower around the sun than Mercury does. It's basic physics. But that's not what she found. Instead, she discovered that stars on the outer edges of galaxies were moving just as fast as stars closer to the center. This was a huge shock. The only way to explain this was if there was a massive invisible halo of matter surrounding the entire galaxy, providing extra gravity. This halo wasn't shining. It wasn't reflecting light. It was just there. This was the same conclusion Zwicky had reached decades earlier. Vera Rubin's work provided powerful evidence that this dark matter stuff was real, and it was everywhere. So we know dark matter is out there because we can see its gravitational effects. Think of it like the wind. You can't see the wind itself, but you can see the leaves rustling and the trees swaying. We can't see dark matter, but we see its gravitational pull on stars and galaxies. Another cool piece of evidence is gravitational lensing. According to Einstein's theory of general relativity, massive objects can bend the fabric of space-time. This means that light from a distant object will bend as it passes by a massive object in front of it, like a galaxy cluster. This acts like a cosmic magnifying glass. When astronomers look at distant galaxies, they sometimes see distorted, stretched, or multiple images of them. The amount of distortion they see is far greater than what the visible matter alone could produce. The extra bending is caused by the immense gravity of dark matter within the cluster. It's literally showing us where the invisible matter is. Okay, so we're pretty sure it exists. But what is it? This is the trillion-dollar question. And the honest answer is, we don't know. But we have some pretty good ideas about what it's not. It's not just regular matter that's dark, like old stars, black holes, or dust clouds. We call this type of stuff baryonic matter. It's made of the same protons and neutrons as you and me. Scientists have done the math, and there's simply not enough of this normal dark stuff to account for the missing mass. The numbers just don't add up. So it must be something else entirely, something exotic, something not on our standard model of particle physics. This is where things get really interesting and a little bit theoretical. The leading candidates for dark matter are hypothetical particles called WIMPs and ixions. Let's start with WIMPs. WIMP stands for Weakly Interacting Massive Particle. Massive means they have mass, which is why they have gravity. Weakly interacting means they barely ever interact with normal matter or with light. They would pass right through you, me, and the entire Earth without ever bumping into anything. This is why they're so hard to detect. They are the ultimate cosmic ghosts. Scientists are trying to catch these ghosts. They've built incredibly sensitive detectors deep underground. Why underground? To shield the detectors from all the other cosmic rays and radiation that are constantly bombarding the Earth's surface. These experiments are basically very quiet, very dark rooms, waiting for that 1 in a trillion chance that AWIMP will bump into one of the atoms in the detector and create a tiny detectable signal. So far, we haven't had a confirmed detection, but the hunt is on. And the experiments are getting more and more sensitive. Then there are exions. These are another type of hypothetical particle, but they're very different from WIMPs. They would be incredibly lightweight, millions or even billions of times lighter than an electron. But there would be a mind-boggling number of them, forming a vast cold sea of particles throughout the universe. Think of it as the difference between needing one big bowling ball to explain the extra gravity, which is the WIMP idea, or needing a trillion tiny grains of sand, which is the axion idea. Experiments to find axions are also underway. These experiments often use powerful magnetic fields to try and convert axions into detectable particles of light or photons. Of course, there are other, more out there theories. Some scientists wonder if maybe our understanding of gravity is wrong. Perhaps on very large cosmic scales, gravity doesn't work the way Einstein's theory predicts. This idea is called modified Newtonian dynamics, or MOND. In this view, there's no dark matter at all. The strange movements of stars and galaxies are just a sign that we need a new theory of gravity. However, MOND has its own problems, and Coulomb to explain all the observations as well as the dark matter theory can, especially things like gravitational lensing. For now, most of the evidence points towards dark matter being a new kind of particle. So, why does any of this matter to us? Well, dark matter isn't just a cosmic curiosity. It's the very scaffolding of the universe. Computer simulations show that without dark matter, the universe as we know it wouldn't exist. The tiny fluctuations in the early universe wouldn't have had enough gravitational pull to clump together and form the first stars and galaxies. The visible matter we see is like the lights on a Christmas tree, but dark matter is the tree itself, providing the structure for everything to form upon. It's the invisible architect of the cosmos. Discovering the true nature of dark matter would be a revolution in physics, on par with the discovery of the atom or the theory of relativity. It would open a window into a whole new sector of reality, a dark sector with its own particles and possibly its own forces. It would mean that the famous standard model of particle physics, which describes all known particles and forces, is incomplete. And that's what makes science so exciting. We're standing on the edge of a huge discovery. We live in a universe where 95% of it is a complete mystery, just waiting to be uncovered. From Fritz Zwicky's wild idea to Vera Rubin's groundbreaking observations, and now to the massive underground detectors searching for ghostly particles. The story of dark matter is a perfect example of human curiosity at its best. We see a puzzle, and we can't rest until we solve it. What do you think dark matter is? AWIMP, an axion, or something else we haven't even dreamed of yet? Let me know your thoughts in the comments below. Thanks so much for watching. If you enjoyed this journey into the cosmic unknown, do you forget to hit that like button and subscribe for more deep dives into the mysteries of our universe. See you next time.
Welcome to the universe of the mind. You'll be amazed of the things that you might find. In a galaxy far, far away, the secrets of our world will be exposed today. All is never what it seems. Is a world created by our dreams? Are we living in a simulation? Is the moon an alien space station? Quantum is quantum does. Nobody knew just what it was. To this day we still don't know, but we won't stop exploring. to the universe of the mind. To the universe of the mind. You'll be amazed of the things that you might find in a galaxy far, far away. The secrets of our world will be exposed today. All is never what it seems. Is a world created by our dreams? Are we living in a simulation? Is the moon an alien and space station? Quantum buzz, nobody knew just what it was. To this day we still don't know, but we won't stop exploring though. Welcome to the universe of the mind.
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 Mind. To the universe of the mind, you'll be amazed of the things that you might find.